Hi. So in this project, we are going to build a machine learning model, and after that, we are going to develop a web application that is going to use this machine learning model. Now, the machine learning model is going to predict the medical cost, right? And so let's first move forward and understand what we are going to do in this project in detail. So we have a data set that contains information about people who have to pay for medical assistance or surgeries. It also states out some of the characteristics of these people, like their sex, if they are a smoker or not, maybe their BMI, and from where do they belong, etc. So we will be using this data set to predict the cost of medical assistance a person might have to pay. Moving forward, let's see the details of the project. Now the project is divided into three parts. The first part is building a machine learning model to predict the medical cost. The second part is where we build a web application that is on Django framework to mount the prediction model. The last is where we deploy this Django project on Heroku using GitHub. So this is the first part. So we start off with building a machine learning model. We use a random forest regressor model and train that model using medical cost data points. Right? That is our main data set. So there is abundant information related to the person from which we are going to extract more information and finally build our model to train that model on the data set. In this particular project, we will also learn about removing outliers and why it is so important. This is the second part where we are going to build a web application using the framework Django. Later on, we mount the model that we built in the previous part onto this Django project itself. This is the last part, that is deploying on Heroku, where we deploy the Django application on Heroku using the connections to GitHub. So now let's move forward to the first part, that was building a machine learning model. So this is the first part of the project where we are going to build a machine learning model that predicts the medical cost for people. So as you can see, the first code block here is to mount the drive folder onto this collab notebook, meaning we can have access to the files stored in our drive folders from this collab notebook. You can see here that the path it displays here is that of content/drive. So from this drive folder, we can now access all the other files and other directories that are present. Next, in the second block, you can see that I'm importing some of the libraries. Now, this is not the list of all the libraries that I'm going to use in this project, but only the libraries that are going to be used for data manipulation and data handling. So the first library is NumPy. It is a library consisting of multi-dimensional array objects and a collection of routines for processes that are required to manipulate or handle arrays. Using NumPy, mathematical and logical operations on arrays can be performed easily and efficiently. The next is Pandas. It is a library for data manipulation and data analysis. In particular, it offers data structures and operations for manipulating numerical values and time series. The last two libraries, as you can see, are the Seabound library and the Matplotlib library. While both of these are used for visualizations of data, Seaborn is a library for making statistical graphics in Python, right? But Seaborn also helps in exploration of your data and visualizing your data in a much better manner as compared to Matplotlib, as Seaborn provides you with much more types of graphs with much more color palette to differentiate and highlight key points in your data, right? So next you can see is that I'm using the function that is read CSV to read a CSV file that is present in my drive folder, right? So this is our data set, and using the head function, I'm able to see the first 5 data points. As you can see the parameter 5 here, right? So our data set is as such not really big. It has 1, 2, 3, 4, 5, 6, 7 columns, from which one is the target column or the column which we have to predict. So you can see the BMI, the sex, the age, if the person had or has children or not, smoker, region, and lastly the charges, which has like really specific point values. But anyways, the first thing that I've highlighted is just the meaning of BMI, what BMI is, and maybe what ratio should be, right? Ideally 18.5 to 24.9 is the ratio that BMI should have, or a person should have as a value of BMI, right? So the next thing is that we are going to predict the insurance cost or the medical cost. And first we are looking for the shape that is giving us the dimensionality of the data set. As you can see, there are 1300, more than 1300 data points having 7 columns. The next function that you see is the describe function, which gives you a statistical input of your data or a statistical knowledge of your data, meaning that you might be getting the mean for all the numerical columns that your dataset has, the standard deviation, the minimum value in that column, the maximum, and the quartile ranges, right? So there are some reasons why you might use this function. First being just to get the statistical knowledge of your data. Second, you can also see that some of the columns have very much different ranges as compared to other columns. For example, you can see that the age column has a minimum of 18 and a maximum of 64, but the children column has a minimum of 1, maximum of 5, but the charges column has a minimum of 1100 and a maximum of 63,000. So you can see that these ranges are very much incomparable to ranges of these columns. So what you can do is either, either go for standard scalar, or go for normalization of your data, which will help you in standardizing the data in the way that the ranges are comparable for different columns. While we won't be using this because the column having very large and very differentiated range is the column that we are going to predict. So we won't be using that here, right? Next you can see is the isNull function and the sum function. So the isNull function is basically telling, or is a function that outputs a false or a true value if it encounters any null value present inside the columns of the data set. And the sum function is taking the sum of all the true values, meaning in the end, this combination of the two functions tells you that in all the columns if there's any null value present or not, and if there are, then how many. So as you can see, there's no null value present in all the columns whatsoever. Next is that we are building a box plot. So what exactly is a box plot? As you can see that there is some kind of a box here with some values and a lot of dot points outside this line. So what box plot signifies is that it helps in, first of all, yeah, let me make it clear why we are actually plotting a box plot. This is because it helps us in identifying outliers, right? What are outliers? So outliers are those values which are very much different as compared to all the other values inside your data set. Meaning, if there's a column that is age, right? We have a column that is age. Now, if there's a value of 445 in that, again, nobody lives that long. So that is an outlier. right? So we plot a box plot to identify the outliers. And what this box plot really signifies is that the values that are mediated inside the columns, then it tells you about the maximum value, meaning that using box plot, it identifies what value is supposed to be the maximum value, what value is supposed to be the minimum value, where the average is lying, and where the other data that are near the averages are lying. So what this helps us is that it understands which value can be considered to be a minimum and a maximum, and then all the values below the minimum or above the maximum are considered as outliers. So as you can see here, the average value is represented by this box, that most of the values are present somewhere here, right? And then the mean is shown by this line, the minimum by this line, and the maximum by this line. So all the points above the or ahead of this line are supposed to be the outliers. And as you can see, there are a lot of outliers for the charges column. Now why I'm taking this is because if you don't remove your outliers, they create interference in your model while you are training the model on the data set. And because of this, what happens is that your data set, oh sorry, your model is not able to perform really well and has a low accuracy. So that is one reason why you should be removing these outliers here, or outliers in all the columns, before moving forward and training your model, right? So next what I did is, same, I plotted a box plot for BMI, and I see that there are some values again that are outliers inside this column also. So what I'm doing is later on, yeah, okay, yeah. So before actually removing all of these, right, what I'm doing is understanding more about the data. So first, what I've done is taken the group by function that groups two columns in a way that we can assess, or we can extract data from these columns. How? See, we have sex column and an age column. And then we have another function that is called aggregate, which is taking the parameter mean and count, right? So what happens is group by groups the data into the categories that are present in sex, which is female and male, and then takes the age values to return the mean of the age values and the count, right? So as you can see, we have a sex that is female and male. Then for female, the average of age is 39.5, while the average for males is 38.9. And there are 662 females and 676 males inside our data set. So this is one way where we can correlate, not exactly correlate, but we can relate one column to another and find other information that might help us in understanding more about the data, right? Next, what I'm doing is finding if there's a categorical data type, that is, if smokers column has categories or not. And it has categories only having two, no and yes, where you can see that there's 1064 no values and 274 yes values. Next, again, I'm using the group by to see if to see the mean values of female and male having children. So for female, the dataset provides that if for the female category of the sex ratio, they have a mean of one child, while male has a children of 1.11. So this really tells you that inside your data set, The females are in general having less children as compared to males, or maybe the males who are actually going for hospitals for and taking on the medical transaction are having more children. Though the value is not really so different or so varied, but as you can see, yeah, the average value for males is higher as compared to the females. Next, what are we doing is that we are building or we are plotting a scatter plot. Now, scatter plot is a depiction of data points regarding again two columns, right? And you can see here that we have plotted the age and the BMI values on the basis of sex. So a blue dot is signified as female, and a cross is signified as male. And you can see that the BMI ranges from 40, 45 to 20, right? Very less values are below 20 and very less values are again above 40. Most are situated between 40 to 20, which again, as you can see, tells you that where we know that BMI values should be between 18.5 to 24.9, the values here really tell you that people are not really that healthy. In terms of BMI, of course, right? Since the value should have been just a little below 20 to 25, but you can see the values are till 40 and are very much dense here. Next, you can see again I've built a scatter plot again on the age and charges, right? So the x-axis depicts the age, the charges, and again on the on the basis of sex. So you can see that as the age increases, there's a upgoing slope that tells you that as the age increases, even the charges that each individual is taking on for medical costs is increasing. And you can see that there's one very distinct line, one a little scattered, again a little scattered. But from here, only one thing is certain, that as the age increases, there is increase in the charges incurred by the individual. And we cannot really generalize on if the female is having to incur more charges or the male. But yeah. So next thing is that we are again working on the age and charges columns, but this time we are categorizing on the basis of smoker, if the person is a smoker or not. And this really tells you that if a person is smoker, he is definitely going to incur more charges as compared to people who are not smokers. Because you can see that across is defining a no, and they are having the least charges, right? You can see some of the crosses here, but above 3000, yeah, maybe above 35,000, you won't be seeing much crosses, but only blue dots, which again depicts that if you are a smoker, you're going to incur heavy charges on your medical costs later on, right? So these were the plots through which you can understand more about your data. And now you can see that I'm removing the outliers, right? So after removing the outliers, my shape, or that is the dimensionality, has also decreased a little. Next, again, I'm finding out the categorical data types, which is the column smoker and region and sex. So these three were the columns that were having the categories inside their column values. So with this, we are going to stop here, and in the next part, we are going to understand how to convert categorical values into numerical values and building. And now let's start with how to convert the categorical data types into numerical ones. So for that, we are going to use the class label encoder, right? What we are doing is importing label encoder and building a function that is later on going to be used for conversion. So we have called the class, we are using the fit function and then the transform function. So what happens is that first a column is fitted, or I would say a column is fit inside the label encoder. It understands how many categories are present and which category is to be mapped with which number. And once it understands that, we use the transform function to replace those string data type categories to the numerical ones, right? This print function is just printing the column name and the classes, meaning the categories that are present inside that column. So we have just built a list, and using a for loop, we are changing the, or we are transforming the categorical data into numerical data. Now you can see that the first column was sex and the classes or the categories were female and male, then smoker, then region, and here you can see all the string data type has been converted into the numerical ones. Next, we are just plotting another graph that is called the correlational graph, right? Actually, the graph is created by this function, and this exactly is a heat map, not the, or I would say the visualizing done is done through a heat map. The values are calculated through the core, that is the correlational function, onto the MEDI, that is our data set in the form of data frame, right? So you can see that, yeah, you can't exactly see that, but the correlational values are actually between -1 to 1, both inclusive. So the reason why we are building a correlational graph is to understand how much correlated one column is to the other. Now, in terms of correlation, it means how much related or influential one column is to the other. Meaning that let's say the age is 0.3 times, not times exactly, but yeah, the correlation between age and charges is 0.3, meaning first of all this is a positive value, right? So this means that age is somewhat able to influence the charges column. That is, if there is going to be a change in age, then there's going to be a change in charges also, but the change is not going to be equivalent, meaning if the value is 1, that is the correlational value is 1, it means that if there's going to be change in column 1, then an equivalent change is going to happen in column 2 also. But since the value is 0.3, which is small as compared to 1, there's not going to be an equivalent change. So yeah, age is somewhat able to influence the charges column, right? But you can see the smokers here, right? The smokers have 0.79 value, which is very high. This means that the smoker column is very much able to influence the charges column, which means that when we are predicting, the smoker column is going to be an essential column for the model to understand how to predict the charges, right? So this is why we are building a correlational graph. Next, so we're just defining our x and y being the target variable. And then, as you can see, we are importing some more functions and classes which are now going to be used for our model building. So we have imported the random forest regressor model, and using the train test split function, we are now categorizing the data into training data and testing data, right? This random state just has or should have a value of maybe non-zero or zero. Zero defining that the splitting of data will not have any random shuffling, right? Next, we are instantiating the random forest regressor model, and now we are using the fit function of the random model and then finding the accuracy for that. So the training accuracy is 97.68%, which is very high. but the testing accuracy is not so high and is 83%. Now from this you can say that yeah, the model is overfitting a little. Well, not a little, but yeah, overfitting. But for the purpose of this project, 83% is an okay accuracy. So I won't be making much changes into the random forest regressor model to fine tune it, but as it is using the random model directly. So with this, we have completed the first part of the project, that was building our machine learning model. And next we are going to build the Django application on which we are going to mount the machine learning model. For that, I've done this one thing, that is to save the model in the form of pickle file, right? Later on, I'm going to use this pickle file itself. This is the second part of the course or the project where we are going to build the Django web application. Now, before we move forward and understand how to work with Django, let's see what Django actually is. So Django is a Python-based free and open source web framework that allows the model template views architectural system. It is a web framework that has a set of components that helps you to develop websites faster and easier. Now, understanding Django, it was said that there is a model template views architectural system. Now, most of you might not have understood what that is. So basically, in a web application, there's going to be a front end, that is interface. There is going to be a back end where things are happening, and there's going to be a storage system where data is stored and retrieved from. So this is what model template views architectural system is. Models are having tables that are storing the values, retrieving the values right from the database, and template is the HTML file exclusively that showcases onto your website when you log in, right? Or maybe when you go to that URL. And views is actually the implementation or backend where data manipulation, data handling, result finding, everything that happens on the backend servers is what views handles. So for this project, we are going to actually use only templates and views only, right? So before moving forward, let's understand how to set up the code itself. First, we have to create a project directory, right? Create a project directory, and for that project, build an environment. If you're using PyCharm like me, right? So go to the files, go to settings. So go to the project and then click on project interpreter. Then you will see that there's a project interpreter. For you, it might be empty or maybe filled. So if it's empty, then click on the settings tab and click on add. Once you click on that, you can build a new environment, right? So this is the location where your environment will be stored and the Python version that you want to use. Once you do that, so then after that, you can just click on OK since your environment has been built. And with that, later on, if you open your terminal, there's going to be this here. That means that your environment has been activated. Next, what you have to do is go inside the my site directory, right? In the code, there's going to be a main my site. Then there's going to be a my site inside the main my site directory, right? Go inside my site and type the command pip install r requirements.txt. Once you do that, then all the existing packages that are required by this project itself is going to be installed, right? Once it has done that, we can move forward and run the command python manage.py migrate. So this command is basically a command for Django specifically that tells Django that you have to now instantiate all the necessary models or all the necessary tables that are required by this base project of Django to run, right? So this is the last command, that is run server, which from the name itself tells that it is going to start a development server on your local machine. So we'll be using that later on. first let's understand how to properly set and navigate the Django application in a way that you want. So first is settings.py. You will find this file inside the my site directory here, right? So first thing that you can see is that it provides you with a secret key which is specific to a Django project, then allowed hosts. So this is so that you can run the project on your local server, and this is to run on the Heroku account or the Heroku server specifically. Later on, you can see that there's installed apps and middlewares. So which means that Django already provides you with a base project which can run on itself. And for that, it has already created some apps and provided you with middlewares like security middleware, sessions middleware, right? Sessions for your website, CSRF middleware, which is used in your HTML pages. So you can see that you don't have to build anything from scratch. You can just use the base project and build upon that, right? Later on, you will see that there's databases also if you scroll down. And here you can connect different databases. You can connect an SQLite 3 database, a Postgres or a MySQL database, right? So you can create and then connect your project itself with different databases. The last part that you have to keep in mind is the static URL and the static root. Now these are required for storing and retrieving static files. And as you can see, static files consist of CSS, JavaScript, and images. So static URL is basically specifying the path where you're going to get the static files from, and static root defines the directory where all the static files are going to be stored, right? So once we have set the settings.py file, we can move forward to views. But before moving forward, let me just tell you that if there's something more that you want to understand, or maybe from my explanation it was not so clear, you can just directly go to the Django docs itself. They have a very good documentation and easy to understand language from which you can maybe understand what I was not able to properly tell you, right? So you can see the link is also provided, and this one is specifically for understanding static files. Next, you can see that there's this my site directory and this polls directory. So my site directory is actually the project directory, and polls directory is actually the app directory. So you can build different apps that have different functionalities for your website, right? And you can actually maintain your project or the website by implementing the settings.py file, or maybe specifying roles in the settings.py file as to where you have to store the static files, or if you want to connect your database, right, and so on. So moving into the app, which is the polls app, it has a template, right, templates folder, which is storing the template, that is HTML page. And now you can see this is just the CSS part, and here you can see there's a form. So what we are doing is actually creating an HTML page onto which a user might go from our URL, and after that he's going to insert the information into the form, and then the form is going to submit that information which will come to the backend. So you can see there's the button. So once you have filled your form, you click on the submit button, then all of that data actually goes into the views. Here what we have done is we have created a function that is called index func, and inside that all of that data is being stored, right? So once you store that data, next what we are doing is we are creating a data frame, right? We have created the data frame, and now we are loading the model. As you can see, that pickle file which we actually stored or saved after we built our model is now being retrieved and used here. So we have mount the model here, and using the predict function we are predicting the result. Lastly, we are sending that result through the render function inside the context. So overall, we are creating a function which is manipulating and handling the data, finding the result, and then sending the result back to the front end. So you can see that there is a return render function. So render function takes in the parameter request, then the parameter HTML page, that which page is to be rendered when we are going to load the index function. And later on, it understands the context. That is, if we want to send back data from our backend to the front end. So with this, you can understand how the cycle goes. First, we are at the front end, we get the data, we send that data to the backend, that is the views. We create a function to find the result. Actually, first store the result, then find the result. Sorry, first store the information and then find the result. Lastly, we send that result back to the front end, right? But one thing you might have noticed that there is no call for this function. We have just defined that, right? So the call for the function is actually in URLs. So what happens is that you have created a path, right? You have created a path which is actually the URL, and once a user goes onto the URL, this function is called. So this path is actually a function which sets the URL onto which this function call will be made. And once this function call is made, views here understand that the function is now at work. So this is how the Django HTML pages first understand that there's some data, they submit that data, right? And once the data is submitted, function is called, function does its function and then finds the result, sends back the result. So with this, you can say that you have at least understood the part where Django is working, and in the cycle phase, what's the first phase, what's the second phase, and what's the third phase. Sorry, phase. Now what we are going to do is run the last command, that was python manage.py run server. So this is going to start a development server onto your local machine and provide you with a local host, right? So as you can see, it's performing some checks and then provides you with a local host URL. So this is the URL, base URL, right? And since we haven't actually inserted any specific path type or path value, like we could have written here something like forms or something like that, but since this is empty, so after that again it is empty. So on this URL itself, we are going to render our HTML page. And now you can see the HTML page is loaded, and you can just fill in the form and click on submit. Once you click on submit, it is going to return you back with the result on the page, and you can see that the cost for me will be 2,110 point something something dollars, right? Which is a lot, by the way. So you can see that the HTML page first took the data, sent back to the views stored the data, used that data, find the results, and then return back the result to the front end. And you can see that here. So with this, we have completed the second part also, that was building and understanding the Django application and how it's working. This is the third part of the project where we will be deploying our web application on Heroku. But before we start with Heroku, we have to use some files which are like commands for Heroku to understand. Now let's start with runtime.txt and procfile. Now runtime.txt is basically just telling Heroku which language or base is to be used by the server. And you can see that we are going to use the Python language and that version, which is 3.7.10. Next is the proc file. Now Procfile is a mechanism for declaring what commands are run by your application in the Heroku platform. The commands that are specified in the last part, like run server and migrate, these commands are executed in Heroku's server using the procfile only. And with that, if you're giving a log file input, then it is going to provide you with the log file also, which tells you that in the server at what time what was happening, right? So the first thing that you have to do now, after you were properly able to set up and run the Django application, is that to upload this code into one of your repositories inside GitHub. So as you can see, sorry, as you can see, if I type in the repository that I used, so you can see that there is a repository, right, medical cost, and inside that I have stored the code. So I have to store the code except this collab, right? This is not needed here. So you can upload the code here, and you can see there's a my site directory that is having the settings.py, polls directory, which is our app, and then proc file, manage.py file, requirements, and runtime.txt. So once you have uploaded your code here, what you have to do is go to the Heroku platform. In Heroku platform, you can just log in into your account, and if you don't have your account, then you can create one. It's very easy. It asks for some of the information like your name, maybe company if you're affiliated to, if you're a student or not, stuff like that. So once you create your account, you will be redirected to your personal page, that is, or your dashboard, that is this this only, right? So you can go to the top right corner where is a button called new, and click on the create new app. Once you click on that, just type in any of the name that you want, then click on create app. Well, I've already created one, which is medical costing. So once you create your app, click on the app itself, and it is going to redirect you to the resources and overview pages, right? So go to the settings page and scroll down to the build packs. Now click on add build pack, click on Python, and click on save changes. Once you do that, Heroku Python build pack will be associated with this app, right? You can see that from here. It is now showcasing here. And then go back to deploy. Now in deploy, it is giving you three methods: Heroku Git, GitHub, or container registry. So you have to choose GitHub Connect, right? Click on this. Then it is it is going to ask you that you have to log into your GitHub account by your credentials. And once you log in, then your GitHub account will be connected to your Heroku account. So once you do that, there's going to be a connect option here, which is asking you to connect one repository from your GitHub account to this specific app. So there's going to be a search option first, then once you search and select the repository that you want to connect, it is going to showcase a connect button here. You can click on that. Once it has done that, it is going to give you two new options, that is automatic deploys and manual deploys. So go on to the manual deploys. Choose the branch in which you have your code. Since I have my code in the master branch, I'm going to choose master and click on deploy. Now this is going to take some time because now Heroku has understood that a server is needed, and now it is going to take your code from your repository and set that up into its server. So you can see that using Python version specified in runtime.txt, it does understand which Python version is to be used. Then it is going to install all the requirements, or I would say all the packages that are in the requirements.txt, right? Then it is going to run a command that is collect static, again with the help of procfile. And collect static is basically a command that tells the server that all the static files present all over the code has to be taken and stored in the static files directory only, right? Static files directory. So once it has done that also, it is going to compress the files and release the server, or I would say release the version in which your server is now running. So once it has done all the processes, then it is going to showcase a view button here, right? Yes, as you can see, a view button is now available. You can click on this and it is going to redirect you to your page. You can just type in anything, right? Click on submit. Once you click on submit, yes, as you can see, the cost is now present. That is our result. So with this, we have completed the third part also, which was deploying our web application